the CEHF Blended Learning course for physical fitness assessment and program design. And this is lesson 8, which is the Astron-Rhyming bicycle ergometer test. The aim of the lesson is to introduce the student to the procedures used when administering the Astron-Rhyming bike test when assessing cardiorespiratory endurance. The learning outcomes: you will learn the procedures used to administer the bike test on a client. You will be able to determine client suitability when administering the test. You will be able to distinguish between the advantages and limitations of the test, and also to work out VO2 max from the result. The equipment needed is a mechanically or electronically braked ergometer. An ergometer is an instrument used to determine the amount of work being done, a timer or a stopwatch, and a heart rate monitor fitted to the client. This test is based on the assumption that a linear relationship exists between heart rate and VO2 max. So as the workload increases, so does the heart rate, and so does VO2 max accordingly. It is suitable for low to good fitness levels, so that's an advantage of the test. You can use it with somebody with low fitness level, moderate fitness level, or indeed a good fitness level. And as body weight supported, it is suitable for overweight clients. Test procedures: adjust the seat height and handlebars, and a simple rule of thumb here is to get the client to stand beside the bike and adjust the seat height to their hip. Sitting on the bike then, their knee in the down position should be slightly bent, not totally locked out, and the handlebars should be comfortable so that they can maintain an upright position on the bike. Set the cadence at 50 revolutions per minute. This can be seen on the dial on the bike in front of you, or you could also set a metronome to this pace, and this would be very handy to keep the client pedaling at the correct speed. Set the workload at 75, 100 or 150 watts for the untrained, the moderately trained or the fit client respectively. Maintain that workload then for 6 minutes. So keep pedaling at 50 revolutions per minute at the set workload for 6 minutes. Take the heart rate, read the heart rate off the pulse monitor at minute 5 and again at minute 6. Now what we're looking for here is steady state. We defined steady state in a previous lesson. We said that steady state was oxygen supply equals demand. Well, how do we know we've got steady state? Well, we'll take the heart rate in minute 5 and minute 6. We'll compare the two heart rates, and if they are within 5 beats of each other, then we know we have steady state. So if we have a heart rate of 130 and 135, well then we know we have steady state. We also need the two heart rates to be between 130 and 170 beats per minute for this test. That is the test protocol. If the heart rate is less than 130 beats per minute, it means that we've started off at workload that is too low for this client. So we would increase the workload by 50 watts on the ergometer and start again. So we would start from scratch again another 6 minutes at an increased workload. If there's more than 5 beats between the heart rates, continue for another minute. So if when you're looking for steady state and the two heart rates are more than 5 beats apart, in other words, you might have 130 and 138, you haven't got steady state, keep going for another minute and at the same workload and see if you can get it then. When two steady state heart rates have been achieved between 130 and 170 beats per minute, well then the test is complete and the client should cool down. What we need to do then is try to establish VO2 max. So we're going to write down the client's age and their weight in kilograms. Write down the watts that the client worked at on the bike and their average heart rate after 6 minutes. Now their average heart rate is, you add the two heart rates together, one at minute 5, one at minute 6, add them together and divide by 2 to get their average heart rate. For example, if their heart rate after minute 5 is 136 and after minute 6 was 140, then we'd add 136 to 140 and divide by 2, which will give us 138. So you can see from that is a good heart rate in the sense that it's between 130 and 170, which is what we're looking for. Okay, so we're going to look at this nomogram here and we're going to try and work out VO2 max, right? So here you've got the pulse rate down the left hand side, you've got the male and the female there, and over on the right hand side you've got the watts. That's the watts you used on the bike. That was the resistance you put on the bike. Okay, and down here you have the age correction table. So we're going to take into account the client's age as well. So we're going to look at an example. So just say we had this client here and he was working at 140, his pulse rate, sorry, was 142 beats per minute having done the 6 minutes, and he was working at 100 watts. So what we're going to do here is we're going to read off litres per minute here on this little sliding scale down here in the centre. Okay, so if we see where the 2 points cross in the middle, and we might read off here, it's around 2.7, so it's between 2.6, 2.8, and what that means is we're looking at 2.7 litres per minute of VO2 max. Right, so we know that VO2 max is expressed in millilitres. So we have a little bit of work to do on this yet. So at the moment we have 2.7 litres per minute. So the next thing we're going to do is we're going to come down here and look at the age of the client. And let's say we have a 35-year-old. So the correction factor for a 35-year-old is 0.87. So what we're going to do with that 2.7 that we took off here, we're going to multiply that by 0.87. So that comes up on the next slide here. So 2.7, which we read off the graph, multiplied by the correction factor for age, and we're taking that the person's age is 35. So if you multiply 2.7 by 0.87, which we read off the little chart there a minute ago, will give us 2.349. Now we're still in litres per minute. Okay, so the next thing we need to do is to convert the litres to millilitres. So 2.349 multiplied by 1000 to convert to millilitres will give us 2,349, and the last thing we have to do is take into account the person's weight in kilograms. So we're going to divide this figure here by their body weight in kilograms. And just for example, say the weight was 65 kilograms. So 2,349 divided by 65 is 36 millilitres per kilogram per minute of exercise, and that's their VO2 max. So that's the answer there. And what we would do with that 36 then is we would go to the standards for VO2 max and see whether or not that individual had good, average, excellent cardiorespiratory endurance. In the next lesson, we're going to look at the treadmill jogging test and the Astrand treadmill test.